you for joining us today. We are here to present our assignment on supervised learning classification. My name is Abhay and I'll be presenting along with my teammate Sai Shreya. Let's dive into the topic starting with an overview of supervised learning.
Supervised learning is a type of machine learning where we train models using labeled data. Essentially, we are giving the model examples of what the output should look like, allowing it to make predictions on new data. There are two types: classification, which is our focus today, and regression. The purpose of supervised learning is to predict future outcomes based on past data. In classification, we categorize data into discrete classes. Next, Abhay will explain what classification entails.
What is classification? Classification is a type of supervised learning, focuses on predicting a category or label for new data based on observed example. For instance, we might predict whether an email is spam or not, which is a binary classification problem, or recognize multiple classes such as identifying different animals in image. The objective is to assign these categories with high accuracy based on learning patterns. Now Shreya will begin explaining specific row models used in classification.
Logistic regression. Logistic regression is one of the most straightforward classification models. It is a statistical model used for binary outcomes like determining if an email is spam or not. The model uses a logistic function to predict probabilities, outputting values between 0 and 1. It is effective for cases where there are just two possible outcomes. Now Abhay will discuss support vector machines, another popular classification model.
Support vector machines or SVM is a powerful model for classification tasks. It works by finding the optimal boundary or hyperplane that separates different classes. This boundary maximizes the margin between classes, making SVM very effective, especially in high dimensional spaces. They are commonly used in text and image classification.
K nearest neighbors or KNN is an instance-based model that classifies data based on the nearest neighbors in the dataset. For each new data point, KNN looks at the k closest neighbors and assigns the most common class among them. It's often used in recommendation systems and pattern recognition. This model is simple yet effective, particularly when we need to make predictions based on similarity. Abhay will now go over decision trees.
Decision trees are structured like flowcharts, with each decision node splitting data based on best features. It's a powerful model for classification because it can handle both categorical or numerical data. We follow branches of tree based on feature value until we reach a final decision or class. Decision trees are widely used in fields like customer segmentation or role approval.
Random forest is an ensemble model that builds multiple decision trees and combines their result for a final classification decision. It reduces the risk of overfitting, which is common with single decision trees, by averaging the predictions from many trees. This approach is frequently applied in fraud detection and financial risk prediction. It is robust and generally yields high accuracy. Abhay will now take us through artificial neural networks.
Artificial neural networks, or ANNs, are inspired by structure of human beings. They consist of interconnected layers or neurons that learn from data. Each neuron applies a transformation to the data and passes it through the network. ANNs are highly effective in complex classification tasks like image recognition. They excel in application where patterns are complex and require layered approach. Now let's look at how we evaluate these models.
Evaluation metrics in classification. When evaluating classification models, we use metrics like accuracy, precision, recall, and F1 score. Accuracy tells us the overall correctness of the model, while precision measures how well the model avoids false positives. Recall, on the other hand, indicates how well it captures all positives, and F1 score balances precision and recall. These metrics are crucial for assessing a model's performance, particularly when classes are imbalanced. Abhay will now explain some common challenges in classification.
Classification presents several challenges, including overfitting, where a model performs well on training data but poorly on new data. This can mitigate with techniques like regularization or cross validation. Another challenge in handling imbalanced data. While one class dominates, this can lead to biased predictions, but we can use methods like resampling to address this. Choose the right model for the next problem is also crucial for achieving optimal result. Next, we will discuss how real-world application works for classification.
Classification models are used across various fields. In finance, they're applied for fraud detection and credit risk assessment. In healthcare, they aid in disease diagnosis and patient risk prediction. In marketing, classification helps segment customers and personalize recommendations. These applications demonstrate the versatility and impact of classification models in solving real world problems. Finally, Abhay will summarize our presentation.
To sum up, supervised learning in classification enables us to predict categorical outcomes, allowing us to make informed decisions across diverse fields. We have covered various classification models from logistic regression to artificial neural networks, along with their evaluation metrics and challenges. Each model has unique strength and choosing the right one is key. Thank you for listening.